So we know that no one single source of electricity can meet our global energy needs. Already we use a mixture of coal-fired power plants and natural gas-fired power plants. So renewable energies will also have to be a mix. So this is the current renewable energy sources that you can see right here since 1990 to current day. Wind power, this one in green, has been on the rise. And so this is in contrast to the pink, the purple, orange, and red. So pink is wood, still stable through the centuries, and waste conversion. That would be the example of biomass. And orange is geothermal. We'll get to talk about that. And then there's a tiny bit of red coming up, and that was the solar that we just talked about. Solar, it requires a lot of installation and setup cost. This blue we'll look at as well. That's hydroelectric. It's gone up and down, but it's been pretty stable, and that's building a dam on a river. Wind power has been used for hundreds of years. The Dutch have been using windmills to pump water for hundreds of years, but we've seen a lot of growth from that last graph in the last decade even. So the bonuses is it's sustainable, it's renewable, it's natural, there's no carbon emissions. It works in conjunction with solar, that when there's no sun, typically there's wind, or when there's wind, when there's no wind, then there's sun. So this can work even on a micro scale, like the solar cell, the small solar cell in a solar calculator. You can have a small, just one windmill. And all countries have wind, just like all countries have sun. Even especially countries that are island countries that have offshore winds. So there are some environmental costs. This giant windmill or even a wind farm is going to ruin the natural beauty of the land as a solar array would. And it does also, similar to a solar array, require lots of land and space. And there's mechanical upkeep, and that's what's slightly different from the solar panels is these moving parts, they have to be kept working and be fixed if needed. So as I mentioned, hydroelectric power is building a dam on a river. This is the Hoover Dam outside of Las Vegas, and this would be the river, but with this dam harnesses the power of the water. As we saw, a waterfall naturally, water naturally moves down and you have energy released. And so what happens is there's energy as the water moves down. It moves actually through these turbines, these towers here. And these turbines, on the other half of the coal-fired power plant, instead of burning coal to move a turbine, what you have is water to move a turbine. So this is what has also been used for hundreds of years. Again, just like wind power, humans have used water to generate energy. This was to grind grain. This is a water mill. And this is sustainable. It's renewable. It's natural. There's no carbon emissions. There's no pollutants. But similar to wind and solar is there's a startup cost. There was a huge startup cost for the Hoover Dam. And you need a river. So there's an environmental cost of damming up a river as well for the fish and wildlife that live in the river. But that infrastructure cost in order to build and maintain is something that can be insurmountable for certain countries. But they're certainly considered sustainable for as far as the emissions and the pollutants. So what is geothermal power? So this is harnessing heat from the core of the planet. This is literally taking Earth's energy that is similar to solar. It's free. Earth heat, geothermal, that's what that means. Geo for earth and therm is heat. So this is done by drilling underground reservoirs drilling into underground reservoirs that contain hot water or steam, and that's heated from the inner core and mantle of the earth. It's location based. You need natural hot springs, you need volcanoes, and this is in the western U.S. We do have these types of hot springs. And so this is sustainable and renewable and natural, but it certainly depends on location. This is an example of a nearby geothermal plant. This is in Calipatria, California. This is actually produces about 5% of California's electricity. It's in the Imperial Valley. The U.S., in fact, currently leads the world in total geothermal electricity generation, though other countries like Iceland that have lots of geothermal, natural geothermal activity, they do have geothermal as well. So it's sustainable, it's renewable, it's natural, there's no carbon emissions, there's no air pollutants. It's unlike wind and solar, it's 24/7. You're going to have this energy emitted from the earth. And so many countries that have natural hot springs and volcanoes, these this has huge potential. So their startup costs, though, drilling deep down into the earth is expensive. And so you can see that these other countries, some small, but there's a lot. Everyone's kind of getting into the geothermal electricity generation. So the way it works is you have radiant energy that's heat that's used to heat up water and boil water and move the turbine that generates electricity for the grid. We know, though, that we need renewable energy sources to replace these fossil fuels. So here's our current day situation is, here's where fossil fuels are. That's the coal, that's the petroleum and natural gas. We need these red and green lines. We just looked at taking all the renewable energies into account. There's still a fraction of the fossil fuels. We need to get this number up here and this blue number down there. Okay. Now what's going to be involved in getting us to replacement is going to have to be nuclear power, and so we'll be getting to that next.